started. So you guys, my name is Blake. I'm from the University of Kentucky Department of Entomology. I do extension entomology. A lot of what I don't do any research, and I'm not on campus very much. I'm extension full-time. So a lot of what I do is this kind of thing, which is going out and talking to Kentuckians, and a whole lot of what I do is youth. So I go out and work with extension agents, the 4-H side of that. So that's a bunch of what I do. Hopefully you are aware that you're getting into some entomology for the Master Naturalist program. We're very happy that entomology is a part of the program because insects are pretty important, as I hope you all will see. We're going to do two things, like I said. First, we are going to explore the water. We're going to do that for maybe 45 minutes or an hour. And then we will try to go back to the Learning Center, and I have sort of a PowerPoint on other insect topics that we will talk about. Insects are pretty important for you guys because one of the best things about them is that they're always around for you when it's time to interpret. So if you're with a crowd and you want to talk about predators, you want to talk about decomposition, maybe you can't find a bobcat that day, but you'll be able to find an insect predator pretty easily. Same thing with a lot of other ecological things that different animals do. Insects do all of those things, and it's going on around us right now. So that's one of the reasons why we think insects are pretty important for naturalists, but also they're just important in the world. They do all kinds of things, as we will see later. But what we are going to do now is a very specific activity involving water insects, and some of you all might have done this before. This is where we actually go investigate the water, pull out the invertebrates that live there, and when we identify them, they will actually give us an indication of how healthy or unhealthy our water ecosystem is. This is a really good skill to know for a whole bunch of different reasons. One of the great things about it is it pulls a lot of topics in together. It shows how insects and water are interacting with each other. It shows how the habitat and the physical characteristics of the stream have a direct impact on the insects that live in there. And then we can also bring in other creatures too. So why do we care? One of the things we're looking at is whether the water is healthy enough to support the insect population that should be there. So why do we care about those insects in there? Do the insects do anything in the water for us that we care about? Can anybody think of any reason why we care about them in there? What did you say? Food for fish is probably the most important. A lot of times when I ask kids that, they'll say because they help filter or clean the water. That's a nice thought, but they really don't do that very much. They do decomposition down there, and they probably help to clean the water some, but mostly the water is sort of doing that itself. But the bugs that are in the water are the foundation of the food system for the bigger creatures. So the fish that live in there depend on them. At some stage in their life, fish are going to be eating bugs. Most of our fish don't eat a lot of plants. I think carp do that. Not a lot of others do that. They're hunting. These fish hunt. So all of our game fish depend on these bugs. So that's why we care about them. But from a naturalist perspective, they're important because they can tell us about water health, as we will see. So let me show you some of the tools that we're going to use. Oh, another reason why this is a good skill to learn, actually two other reasons. For one thing, it's something you can do almost any time of the year. So if you're a naturalist, you're outside and it's cold, even if it's winter time, as long as the water isn't frozen, those creatures are still down there active. So this is something that you can do when you have a group of people for some reason in January, and as long as, like I said, if it's not frozen or as long as the water's not too high to get into, you will find the creatures there. So it's a good skill to learn for that. It's sort of an all-weather activity that you can do. And also, this isn't just an educational activity, this is a professional activity. Looking for waters in the stream and measuring water health based on what you catch is something that professionals do. There's at least two groups of people that do this professionally. Kentucky Division of Water, so government employees go around and they sample the insects, and it gives them a portrait of water health. And then also independent consultants will do this too. They will go around, like if somebody wants to build something in a new area, maybe want to see what the impact on the stream is. Those people might go in before and after to see what the insects are, to give an idea of impacts of some human construction or something like that on water quality. But let me show you some of the tools that we're going to be using today. The version that we're going to be doing of this today is what I call the light version. There is a more advanced version that you kind of have to go to Kentucky Division of Water and they teach you. It takes at least a half a day to learn it. But we're going to do a quicker version that will still give you a pretty good indication of water health, and is also something that you can do with just a group of kids or a group of adults with very little training. So be aware that there is a even more advanced version of this. But the tools that you need to do this are pretty basic. You need a white pan. This is important because the creatures you're going to be catching in there, you need to bring them up. So you catch, bring them up, and then you put them in the white pan, because then you can see them pretty well. If this was a dark pan, you couldn't see it, or even if it was a clear pan, you'd see the dirt beneath you. So white pan is really good. You also want to fill this with a little bit of water, and try to keep, as you collect creatures, you want to try to keep from adding debris in here. So you want to see the creatures. So you need a white pan. Oh, the most important thing that you need, by the way, is a sight. And this particular test that we're doing, we call it a macroinvertebrate assessment. It needs to be done on a running stream. That's the result that you get from it is only accurate in a running stream. You can still do a water investigation anywhere. There'll probably be bugs even if it's a ditch. You'll find some bugs and you can look at them and learn about them, and it's really cool. But the specific test that we're doing today, it won't give you an accurate result unless it's a running freshwater stream. So you'll need that. You'll need a stream that you can get into. So you'll need, for safety purposes, you need to find one that's accessible. People need to be able to walk into it. It can't be too high because that could be dangerous. The creatures will probably still be in there. But, and then you need to pick a day when hasn't been a deluge of rain. And so today is a pretty decent day. The water's a little high. We would prefer it to be a little bit lower, but this is okay. So you need the white pan, you need a stream, you need a net. This is actually, I consider this optional for this sort of the light version of the testing that we're doing. But if you were doing this professionally, you would absolutely have to have what we call a D-net. This is useful for a couple of different things. Most of the searching we're going to be doing today will just be by hand, but we can use this as a way to catch several creatures at once. The way it works is, so the bag goes this way, and the stream is going this way, so you would want the bag going this way, downstream, and then you can just sort of kick rocks in front of it. And the creatures that are living under those rocks will get dislodged and then go into the net. Then you can pick it up and start taking things out by hand and putting them in the bucket. Some other things that you will need is a data sheet. This data sheet we'll show you a link to it later. We have it online. It has sort of a checklist of the most common invertebrates that you'll find in the water, and they're divided into 3 columns. And the columns are sort of a different scoring system. And the way this works is when you catch a creature and you bring it back, you check it off, and it doesn't matter if you catch any more or not. Once you found it, it counts, and it's just presence or absence. It doesn't matter how many you find. The more advanced version of this, you'd actually count lots of creatures. But in this, it's just presence or absence. And the way it's divided is the creatures over here on that's the left. Yes, the left. Those are considered the creatures that are going to be highly intolerant of water impacts. These are creatures that need pretty much pristine conditions. They need a lot of oxygen. They need lots of places to hide. And they can't tolerate any kinds or very little impairments. So those creatures over there, they're worth 3 points each. So they're worth more. So now you can start to see how the scoring system works. The creatures in the middle can tolerate maybe a little less oxygen, maybe a little less shelter. Those would be creatures like crayfish, are a little bit, think of them as a little bit tougher, more self-contained. Those creatures are in there. And then the ones and they're worth 2 points each. The ones on the very right are creatures that can live in almost any kind of water conditions. Their presence does not mean that the water is unhealthy. But if they're the only thing that you find, like if you find just snails and just leeches and none of these other creatures, that is sometimes a bad sign. We'll talk about some of the creatures that are associated with very healthy water. We'll talk about them hopefully a lot today. But some of the most important ones are mayflies, so mayfly nymphs, stonefly nymphs, and caddisfly larvae. Those creatures need highly oxygenated water. Kentucky streams, for the most part, are supposed to have a lot of oxygen in them. They're supposed to be, in the old days, many of them would have been shallow for many miles of their lengths, even the rivers. But when you start to channelize things and change streams and rivers and put in dams, it changes the ecosystem a little bit. Things like mayflies, stoneflies, and caddisflies can't live there anymore. The score goes from 0 to 30, and so one of the things I will ask you guys is, well, I'll ask you in a minute, but so you can start thinking about it, is looking at this stream and thinking about what might this stream have looked like 10,000 years ago compared to what it looks like now, and then also think out and comparing to maybe a stream that runs through downtown Louisville. Where do you think that number might be in here? Is it closer to 0 or closer to 30? That pristine mountain Kentucky stream from 10,000 BC would definitely be a 30, and that urban stream might be closer to 0. You know, where would this one fall? And we'll talk about how to make some of those predictions a little bit later. A little bit about the word macroinvertebrates. The creatures that we're going to be looking for today are the invertebrates that live in the water. So the insects, things that are related to insects, like crayfish, and we may find a few other things like that. And then any kind of worm that you see, anything that you would think of as an invertebrate. We call it macroinvertebrates. Does anybody know why we use the word macro instead of just water invertebrates? Why we call it? You can see them. We're not collecting bacteria. Technically, a bacteria is an invertebrate. It's an animal that doesn't have a bone, doesn't have any bones. We're not going to collect really small arthropods, like there's some mites in here that would be too small for us to see. So we're collecting the macroinvertebrates, those things that are big enough for us to physically pull out and look at with the naked eye. And I think that's about all we need to know to get started. A couple other safety issues. When you're bringing kids in here, a lot of times they will ask, and even adults, they will ask, what about the snakes? And those of you who've spent a lot of time in Kentucky probably know that we are unlikely to see a snake today. And if we do see a snake, it's probably going to be a queen snake or a water snake, which are not dangerous. Venomous snakes don't really like lowland water areas in this part of the state anyway. If we were doing this lecture, if we were doing this in western Kentucky, you might see some cottonmouths in lowland water areas. But in this part of the state, I've never seen a copperhead in or near water. My snake friends say that sometimes they'll go across water, but they don't really hang out there. Water snakes like the water, and we might see some of those. They're harmless. The most dangerous thing in here to you guys and to kids and anybody else is just sort of the usual things of life, like slipping and falling. And obviously water can be dangerous in and of itself. And then there's always the possibility of infections from the water. So we do ask people to be careful, especially when you're bringing kids in. Maybe don't bring anybody in with opened, oozing wounds. That's not very good. And then try to clean up afterwards. Maybe even bring hand sanitizer if you're working with kids, or try to get them to a bathroom so they can scrub down or something like that. So who has questions before we actually start digging into the water? Here we go.
What are the limitations on that list of species? Like, why are those there? Because I'm sure it limits some of them, right?
The limitations in what sense? On
that list, in those 3 columns, that's specifically for Kentucky, right?
Oh, this pretty much covers the whole United States, but it's not. We'll talk about this more later, but this isn't to species level. The species that we could find in here might be hundreds, but like mayflies, for instance, there's a few dozen species of mayflies.
Okay.
So any mayfly counts on this test. The same thing is true for stoneflies. There's a few species of stonefly, but we're just looking for any stonefly. So if there was an actual species checklist, it would be much longer. So the limitation is they're limited to, most of these are either at the order or the family level of creatures. So that's how we limit it, is by groups that you can quickly identify. That's a good question. What are other questions that you guys have? So the way we'll do this, if we were doing this the more advanced version, we would actually measure spaces and we would do it a certain amount of time. But when we're doing with kids and when we're doing what we call the light version, we just get in and start hunting, and we sort of stop when we get bored. Usually in my experience, it takes 20 or 30 minutes, and getting bored for me is when I stop finding new creatures. So once I've sort of found all the diversity and I've been looking for 10 or 20 or 30 minutes, that's usually when I wrap it up. Today we'll maybe go a little longer or a little shorter, depending on, maybe we'll find lots of things. If you find vertebrates, fish or salamanders, go ahead and bring them up too. They won't count on our checklist, but we can still look at them. Their presence is always good. I can't think of any cases where a vertebrate wouldn't be good unless it's something like an invasive carp or something like that. So those are always a good sign. Any other questions before we get started? Yes.
What do you usually say about hurting the animals or making sure they stay alive?
That's a really good point. I'm always very careful personally not to hurt them, but sometimes people are grabbing. But yeah, this is a catch and release. If you do it the right way, you can gently get these creatures. Most of them are going to be clinging to the bottoms of rocks. So you can either gently sort of scoop them up with your hands, or a lot of times you can take a leaf, a bigger leaf than that one, like a leaf like this one, and sort of scoop them onto the leaf and then put them in the water. But yeah, I do try to be ethical with these creatures. If you kill a few of them, you're going to be walking through, so you're killing them as you're walking. You can't not kill them. But from an ethical standpoint, and from a standpoint of trying to teach people to be ethical, we usually try to say catch and release. We'll be respectful of these creatures, and we'll let them go afterwards. And by the way, before I want to ask you guys for your predicted score here in a second, but just a little bit about why these creatures are or are not sensitive to impairments. So the ones like mayflies, stoneflies, and caddisflies, I think I mentioned, they're highly dependent on oxygen. And that's one of the biggest limitations as to where you find them. A lot of kids, for instance, will say, when I ask them, what do you think the biggest water pollutant or impairment in Kentucky is, they'll say, gasoline, chemical spills, stuff like that. And those things are definitely really bad. But you guys know some of the biggest impairments, at least from the creature's perspective? Sediment is really bad. Sediment is just, it's washing off of the edge of those banks over there. When you have a construction site, a lot of exposed dirt, it just gets washed into the creeks. That causes several problems. One of the biggest problems for the creatures is that it gums up all the little rocks where they would normally sit and hide underneath. So they can't get there, and they're not strong enough to sort of dig through that sand. So it disrupts their habitat that way. And it can also change the temperature by just clouding up the water, and you get a darker color that absorbs more light. So that's really bad. And another really bad impairment from these creatures' perspective, can anybody think of another one? The sediment is the one really bad one. Fertilizer is pretty bad, but not as bad as one that's even more obvious than that. Sewage, no. Sewage is bad too. These are all bad. But think about that urban stream in Louisville. What's something that it doesn't have that this has? Shade. Trees. When we steal trees from the sides of streams, that is one of the worst things that we do. For one thing, more sediment, because you have less stuff holding the dirt together. But this shade is very critical because it keeps the water temperature lower. And does anybody know what that does to oxygen? Yes. Just a little bit of shade, even in the hot summertime, makes a big difference to the temperature. Cooler temperatures mean more oxygen, and once that stuff heats up to that sort of the exposed sunlight temperature, things start dying quickly. So that's why these things are so sensitive, is because they need a lot of oxygen. When you start taking their oxygen away from them one way or the other, they suffer quickly. You will see, hopefully, once we catch some of these things, you can see their gills, you can see them moving. These things, the water is almost like a part of their body. So when the water quality changes, they change quickly. Any other questions before we dig in? Yes. Yes.
So I'm looking at it right now, but the water data on USGS.
Okay.
This is measured in Fisherville,
Okay.
You can look at the CFS and everything, but it has a part where it says dissolve oxygen. And it has an instantaneous value of 6.5. Is that like
6.5? What units does that say?
It doesn't say. That's what I was gonna ask.
Probably milligrams per liter for oxygen.
Okay, I think I always hear it in parts per million.
Same thing.
So is 6 good?
It says milligrams per liter.
Okay.
This is lower, so I would expect a healthy stream to probably be at least 8 milligrams.
Really?
Really?
More of oxygen.
Wow.
But
Okay.
it gets lower. So there's certain biotic species like fish, that sensitive ones that'll need a certain oxygen level, different ones. But I would expect on a stream like this to be in, I would guess 7 or 8 before I walk in.
Wow.
Okay, well let's eat it then and look.
Yeah, that's interesting. And now, so just looking at this stream, do you think would you say that this is a stream where you would expect to find a lot of macroinvertebrate diversity and get a high score, or maybe a little less?
Yeah, I classify mid to high. Got lots of places for them to live.
We got rocks that we can see that don't seem to be at least totally covered with sediment. We have what around us? We have lots of trees. This is pretty much what you would consider 100% canopy coverage here. It doesn't fully cover the stream, but most of the banks have trees on them. The riparian zone, which is how far the trees go back this way, is not great. You can imagine, once again, 10,000 years ago, it would go back really, really far until maybe you got to some meadow or something like that. But here it only goes, a few yards in this direction, and not sure how far it goes in that direction, but it's not bad. It looks pretty good compared to a city stream that's in concrete or something like that. So we're thinking this might be somewhere in the middle, maybe somewhere on the high end. Are we ready to start getting in the water?
Yeah.
Okay, so I think we'll let you go, at least initially, just about anywhere you want to go within so that we can see you. The rocks are in that direction. The creatures at least some of the creatures are going to be more likely under the rocks. So some of you might want to focus your efforts there. There will also be maybe a separate set of creatures clinging to these weeds. What do we think, Wayne, these things were? A water willow, is that what you said it is? Okay. But aquatic weeds or aquatic plants, I shouldn't use the word weeds. Aquatic plants sometimes provide a different additional habitat for some of these creatures because they cling to them, and they'll actually sit in the water column clinging to these plants instead of hiding under rocks. This part here seems to be pretty deep, so you can either maybe try to go up and go down through there or wade through here, but let's start getting wet if we're ready.
Bring them back into here.
Yes, and we have several buckets. You guys can spread the buckets around. You can take some with you. I'm going to just keep one data sheet, and I'll bring it up here. We don't have to fill out any data yet. Just start collecting creatures.
And so, sorry. I've got other tubs here.
Yeah, we got more tubs. We'll look at some samples here.
Want to do that later?
Yeah, we'll look at the samples later. And if you want to start, if you maybe don't want to get in the water today or unable to, you can start looking at some actual samples. And this is also, might give you an idea, this would be a good project for a naturalist who is maybe working or volunteering for an agency.
I use this in classes all the time.
Do you know where you got this one?
Division of Water.
Okay. Yeah, so you can make one or sometimes buy one.
We're gonna maybe try to get together.
And if you want to see, I've got some of these I use with my class. These are the ones Division of Water has, but Blake also has one too. And there's something here that if you just want to look through and maybe see what some of these are as you're going.
Know what to expect.
This
Yes.
is waterproof.
I'll take one of those,
So
please.
you can.
And by the way, none of these creatures are dangerous to you. The worst thing that could happen to you is a crawdad pinch. So we don't have any dangerous creatures in here. Crawdad, I'm from Moorhead, Kentucky.
Yeah, I got all these. These are Division of Water.
We've also got...
A group of kids into a little pond at our nature preserve. They're looking for frogs and turtles and such. And one of the girls overtopped her boots, and we were out there playing and all that. We came out, and she had about 25 leeches on her.
Oh my gosh!
Yeah, it was an incredible.
Whoa!
Can I look at your
Incredible experience.
Yes.
This is one of my favorite things to do
Like,
with
do you think
kids.
there's
And
a
then
place
if
for
you
me to
get
go
into
kinda
this stuff a lot, I use a lot
Get in a little bit,
I adapt a
you
little
know, like I go on the bank and like lay on my stomach. And
Yes, that would work. That would work really well on those rocks if you can get over there. But maybe we can see if there's a shallower spot. That actually is something that I do sometimes. If I don't want to get wet, I'll do exactly what you just said.
Garbage bag, but I don't think it's
Yeah.
It's not like a dry bag, you know.
Oh yeah.
I don't think I can handle too much, but
Yes, the D-nets are great on the weeds too. Let's look up.
I guess I can just kind of
I'm
turn
gonna-
around and look. I probably wouldn't be able to bring anything back, but at least I can hold some stuff in my hand.
Well, you can get a feel of what it looks like in the water and what it looks like under the rocks.
If you have one of those longer nets, I might be able to kind of just lay and
That'll work. Carmen's net is telescopic.
Okay.
So you could actually even do that maybe from up here. But yeah, I don't know if there's anything on this side that's accessible. You could definitely get down with the net down here, but this isn't ideal sort of rocky, riffly habitat for creatures.
Yeah, I see some good rocks over there.
Yeah,
I don't know if I can get down to them.
yeah.
I'll see if I can grab her.